Hi, this is Terry. Today I'm looking into the confusion and difficulties I ran into when installing ComfyUI on Arch Linux. Now, ComfyUI is an absolutely incredible AI video editing program, and I can't wait to try the capabilities. Likewise, Arch Linux is fantastic, and without the AUR ComfyUI package, I would never have had the opportunity to try it. A big thank you to the Arch Linux and ComfyUI developers. You folks rule. But I did have a few installation problems which this podcast will discuss. They may have been due to the fact that I'm 72 years old or just plain dumb. Maybe it is easier to install on Windows, but I kind of doubt it. I'll post a follow-up video after I've absorbed the AI deep dive and successfully installed everything. Thanks for listening.
Imagine downloading, what's universally praised as the most powerful AI image generator on the market. You hit the generate button, and you realize the software is just entirely hollow.
Right. Yeah, it's literally just a shell.
Exactly. And that is the exact reality of installing ComfyUI on Linux right now. Welcome to the Deep Dive.
Glad to be here.
So today we're looking at a very revealing set of source materials. It's this incredibly detailed technical breakdown of installing and configuring ComfyUI on Arch Linux, specifically version 227.0-1 from the AUR.
It's honestly a fascinating ecosystem to examine because, ComfyUI genuinely is one of the most powerful node-based interfaces out there for generating AI imagery.
Oh, absolutely.
It connects to all the major diffusion models, the flexibility is just unmatched, and the open source community has completely rallied around it. But the actual journey from installing the package to getting your very first generated image, that is an undocumented wilderness.
It's a total scavenger hunt.
Yeah.
And our mission today is to give you, the listener, the map to that wilderness. We are going to provide the essential, unstated checklist that the software itself, frankly, completely fails to hand over.
Okay, let's unpack this because the core tension here is wild. You install this framework, it presents itself as this beautifully finished turnkey product, but underneath, it's missing the actual engine.
It is a really jarring onboarding experience. And, if you're listening and you've ever felt frustrated trying to set up any open source AI tool, your feelings are entirely valid.
Yeah, you're not alone.
Not at all.
Yeah.
The technology is advancing at this breakneck speed, but the user experience, it just hasn't kept up. It still heavily relies on this assumption that you already know the intricate, unspoken rules of the AI landscape before you even type the install command.
Right. Let's start with the installation itself, actually, because that's where the illusion of simplicity really begins. If you are on Arch Linux, the initial process is genuinely impressive. You just run one single command in your terminal pacman-s ComfyUI.
That is it. It downloads the package, it builds it, installs it.
And we really should take a moment to commend the Arch AUR packaging here, because if you were doing a standard manual installation from the official ComfyUI GitHub repository, you'd be pulling down code, manually setting up your own Python virtual environments.
Which is a huge pain.
Huge pain. You're installing dependencies one by one, and you're likely running the whole thing right out of your personal downloads or home directory.
Which feels like a recipe for a very messy file system down the line.
Oh, it is. And it's also, frankly, a mild security risk to just have arbitrary execution environments sitting in your personal folders. So the AUR package provides vastly superior system isolation.
How so? What is it doing differently behind the scenes?
Well, when you run that pacman command, it quietly creates a dedicated system user and group, both just called Comfy. Yeah, and it neatly places the application code into an isolated opt-ComfyUI directory. It sets up a perfectly quarantined Python virtual environment right at opt-ComfyUI-v. And best of all, it cleanly separates your outputs, placing all your generated images safely into a varlib ComfyUI output.
Okay, so that is proper, clean Linux architecture.
Exactly.
But, and here's the catch, it also introduces the first little bump in the road for a newcomer. Because it's packaged so securely, it installs flawlessly, but it ships completely disabled.
Right.
Which, is a standard security practice for system-level packages.
Yeah.
You don't want arbitrary services running without your permission, but the software doesn't actually prompt you to turn it on.
No, it doesn't. You have to just magically know the specific service management command to start the background daemon.
Which is system enable, now ComfyUI.
Right.
So you type that in, the background service spins up, you eagerly open your web browser, navigate to localhost on port 8188, and what you see is stunning.
It really is a beautiful interface.
You're greeted by this highly polished web UI. And right in the middle is a template gallery with over 100 ready-made workflows.
And the presentation there actively sets an expectation. It's an incredibly sophisticated setup.
Yeah, you see templates for things like Candy Image using Z-Image Turbo or Depth of Video with LTX 2.0, audio generation nodes, frame interpolation tools. You are scrolling through this gallery feeling like you just unlocked a superpower.
Yeah, you're ready to make a movie.
Exactly. You pick a workflow that looks amazing. It loads this complex web of interconnected nodes onto your screen. You type in a prompt, and you confidently click the Q prompt button.
And that is the exact moment the entire illusion falls apart.
It really is. It's exactly like, okay, imagine you go out and buy a luxury sports car, right?
Okay.
The paint is gleaming, the leather seats are perfect, the dashboard looks like a spaceship. You sit down, you turn the key, and you just hear this sad little click. You pop the hood and realize there's literally no engine inside.
Just an empty bay.
Right, you just get a tiny red error message on your screen saying file not found.
What's fascinating here is that the sophisticated UI is actively working against your understanding of the situation. It acts as if you're ready to go, you know? It entirely fails to disabuse you of the notion that you are missing gigabytes upon gigabytes of required model files to actually make those template workflows function.
It doesn't pause and say, hey, we need to download some core assets first. It just lets you click go and then crashes into a vague error. And that brings us to the physical reality of what is actually sitting on your hard drive.
Yeah, the empty mansion.
Right, because we have a system that is perfectly isolated, but basically legally forbidden from giving you the files you need to actually use it. If you go digging into your file system, you'll eventually find the UpComfyUI models directory. And inside that directory, there are 27 different subdirectories.
27 specific, highly categorized folders.
I'll just list a few so you get the picture. There is a folder for checkpoints, one for clip, ControlNet, LoRa's, VEI, upscale models. But if you open them up, they're completely empty.
Well, mostly empty.
Oh, right. To be precise, inside the checkpoints folder, there is a tiny text file literally named put checkpoint share. That is the full extent of the documentation provided.
It's pretty brutal.
So that leaves the user with a massive problem. Where on earth did these missing pieces come from?
Right. And to be fair to the developers, this empty architecture is a necessity. It's driven by legalities and physical file sizes. AI model files are massive.
How massive are we talking?
A single base checkpoint can range anywhere from 2 to 12 gigabytes. And furthermore, these models are trained by completely different organizations, from Stability AI to independent researchers. They all carry wildly varying licensing.
All right, so they can't just bundle them together.
Exactly. ComfyUI, as an open source routing framework, cannot legally bundle and distribute those proprietary or restricted weights. Shipping empty directories is really the only viable legal path they have.
The legal aspect makes total sense. But man, from the user's perspective, this is a massive pitfall, particularly regarding storage, because we are not talking about small plugins here. A Flex checkpoint is around 12 gigabytes. An SDXL model is 7 gigabytes. Even the older Stable Diffusion 1.5 models are 4 gigabytes.
They add up incredibly fast.
Oh yeah, if you start downloading just a handful of these to play around with different styles, you can easily fill 50 to 100 gigabytes of disk space in a single afternoon.
And we really need to pause and highlight that as a critical architectural warning for anyone listening. Because the AUR package installs everything strictly into UpComfyUI models, you have to ensure that whatever partition holds your up directory has substantial free space.
Because on a lot of Linux setups, the root drive is partitioned pretty small, right?
Exactly. If you're running a Linux system where your root drive is on a small, tightly partitioned SSD, downloading a few of these models will fill your drive instantly. You could potentially crash your operating system. You have to be deeply aware of where these gigabytes are landing.
Okay, so knowing that the models are massive and entirely missing, how do you actually acquire them? What is the journey for a typical beginner trying to get that sports car and engine?
It's a bit of a loop.
Yeah, it usually goes like this. You hit the Q prompt button, you get a missing checkpoint error, you copy that exact error text, paste it into Google, you eventually land on a third-party site like Hugging Face or Civet AI, you find the model, you click download on this massive 7 gigabyte file.
And your web browser does what web browsers do. It automatically dumps that massive file straight into the downloads folder in your personal home directory.
Exactly. A directory that ComfyUI, which is running as a separate system user in its isolated opt environment, knows absolutely nothing about.
Right. It has no permission to look there.
So now you have a 7 gigabyte file sitting in your downloads folder. You somehow figure out you need to move it to the ComfyUI models folder. You look at those 27 empty subdirectories, and you literally have to guess where it goes. You guess wrong, you try to run the prompt, you get another error, you try again. It is just a maddening loop.
It is incredibly frustrating, mostly because it requires domain knowledge about AI model architecture that you simply haven't acquired yet.
But wait, let me push back on this. If I'm downloading a 7 GB file, how are you supposed to know which of the 27 folders it goes into? Doesn't the file extension tell you? If I download a checkpoint, shouldn't it be called something like, model.checkpoint?
You would certainly hope so. But the file extensions in the open source AI world are incredibly ambiguous. The most common extension you will see today is .safetensors. Now, a safetensors file is essentially just a secure container format.
Wait, why is it called that? What is it keeping safe?
So it was developed to prevent malicious code execution. Previously, AI models were distributed as .ckpt or pickle files, which could secretly execute arbitrary Python code when you loaded them.
Oh, wow. That's a huge security vulnerability.
Massive.
Yeah.
So the safetensors format fixes that by only containing raw mathematical weights, no executable code. Naturally, the entire industry adopted it, but the unintended consequence is that a checkpoint, a VAI, a LoRa, and a CLAP model can now all share the exact same safetensors file extension.
You're kidding.
Nope, the container doesn't tell you what is actually inside it.
Wow, so you just have a bunch of giant files with the exact same extension, and you're supposed to magically know what role they play. That cognitive load is way too high. So let's slow this down. We need to build like a decoder ring for these template workflows for the listener.
Good idea.
Let's start with checkpoints. What are they and where do they go?
Checkpoints are your base models. They are the core engine of the image generation process. These are the massive files we talked about, usually 2 to 12 gigabytes. They define the broad capabilities of the AI, whether it understands photorealism, anime, or 3D renders. These files must go into models checkpoints.
Okay, so the core engine goes into the checkpoints folder. That makes logical sense. What's next?
Next are VAEs, or variable autoencoders.
And what does that actually do?
Think of a VAE as the translator between the AI's brain and human eyes.
Okay.
The diffusion model doesn't actually paint invisible pixels. It operates in a highly compressed mathematical realm called latent space. When the generation is done, the VAE is responsible for taking that math and translating it into the actual PNG image you see on your screen.
Got it.
These also use the safetensors extension, but they are much smaller, usually just a few hundred megabytes, and they belong strictly in models phase.
So you could literally have two .safetensors files sitting in your downloads folder. One is a 7 GB core engine, and the other is a 300 megabyte translator. And they have to go into completely different folders to work.
Precisely. If you put a VAE in the checkpoints folder, the software won't even see it. It'll just pretend it doesn't exist.
Oh.
Then we have LoRa's, low-rank adaptations.
How do those fit in?
Think of a LoRa as a highly specific, lightweight patch you apply on top of the base model. If the checkpoint is the entire car, the LoRa is a custom paint job or a spoiler. You don't need it to drive, but you need it to achieve a very specific look.
Oh, I see.
People use them to add specific characters, art styles, or objects without downloading a whole new 7 GB engine. They range from tens to a few hundred megabytes, and they go into model LoRa's.
Okay, so LoRa's are basically custom-style filters. What about the text you actually type in, like the prompt itself?
That is handled by text encoders, often referred to as CLIP models. These are the components that actually read your written text prompt and translate human language into concepts the AI can understand. If you tell it you want a red apple, the CLIP model figures out what those words mathematically represent.
And how big are those?
Usually a few hundred megabytes to a couple of gigabytes. They belong in ModelSCLIP or sometimes models text encoders.
Okay, that covers the big ones. And I know some workflows use upscalers to make the images high resolution or ControlNet to guide the image using depth maps.
Yes, upscalers like the popular ESR-Jan models go into model subscale models. ControlNet models go into models ControlNet. And finally, embeddings, which are small custom concepts often called textual inversions, they go into models embeddings.
All right, let's recap this process. You've graved the scavenger hunt, you downloaded your .safetensors file, you used our little decoder ring to realize it's a VAE, so it belongs in the VA folder. Now we have to talk about the physical sequence of getting it there to fix that file not found error.
Right, the fun part.
Because of that strict Linux system isolation we praised earlier, you can't just open your graphical file manager and drag the file from downloads into the opt folder.
You can't. Because the OptComfy directory is owned by that hidden Comfy system user, your personal user account doesn't have the permissions to write data there. If you try to drag and drop, Linux will just throw a permission denied error.
So here is the manual resolution sequence you actually have to use. You open your terminal, you type sudo tp, downloads followed by the name of the massive model you just downloaded, and you copy it to opt.comfyo models, followed by the correct subdirectory we just went over.
Yeah, you have to use sudo to invoke administrative privileges to forcefully place the file there.
And placing the file in the correct folder is only step one.
Right, because the background daemon running ComfyUI doesn't dynamically watch those folders for changes. It has no idea you just dropped a 7 GB file in there.
Exactly. So you have to restart the engine. You run the command system ltoa to restart ComfyUI. Then you go back to your web browser, you refresh the page, and you verify that the model is successfully loaded.
And the way you verify that is by checking the actual nodes in your template workflow. If you click on the drop-down menu of a load checkpoint node, the model you just copied over should finally appear in the list.
It is just a meticulously tedious sequence. Download the file, open the terminal, run sudo create to the correct folder, restart the system service, refresh the browser, and verify the dropdown. And you have to repeat that exact sequence for every single missing component.
Yeah.
A complex video generation workflow might require a specific checkpoint, a separate VAE, 2 different LoRa's, and a dedicated upscaler. I mean, it literally takes hours.
Which naturally leads to the question, is there any way around this?
So what does this all mean? Is there an easier way to manage this? Are we just condemned to moving files around in the terminal forever?
Well, there is a bypass, and it's important to note this, it's really only designed for people who already have a deep footprint in the AI ecosystem.
Ah, okay. Let's talk about the configuration file. There's a specific YAML configuration file hidden in the etc. folder. We won't make you memorize the exact path while you're driving, but it's the extra model paths file. It's located at htc-comfy extra model paths.yaml.
Yes, and YAML is just a standard configuration language. Now, if you open this specific file, it's about 43 lines long, but almost all of it is commented out, meaning it's just plain text instructions that the system ignores. The only active code right out of the box is an empty placeholder.
Just 2 blank curly braces at lines 11 and 12, right?
Exactly.
So it functionally does nothing for a fresh install.
Nothing at all. But if you look at the commented instructions, it reveals a massive shortcut. Let's say you are a user who previously spent 6 months using Automatic 1111's Stable Diffusion WebUI. You already have a massive library of checkpoints, LoRa's, and VAEs sitting on a separate hard drive.
Right, and you absolutely do not want to duplicate 100 gigabytes of models just to try out ComfyUI.
Exactly. So you open this YAML file, you uncommented the example block, and you define an external path. You set the base path variable to point directly at your existing Automatic 1111 folder.
Oh, that's smart.
If you do that and restart the service, ComfyUI will magically reach out, scan that external folder, map all those 27 subdirectories perfectly, and find all your existing models. It's an incredibly elegant way to integrate your past work.
Which is brilliant engineering. But it perfectly illustrates the central problem. If you are a first-time user, if you don't already have an external hard drive full of AI models from a different piece of software, this config file is entirely useless to you. You are stuck doing the scavenger hunt.
It really highlights a recurring theme in advanced open source software. The architecture is incredibly powerful, secure, and accommodating for power users who already understand the ecosystem. But the onboarding ramp for newcomers isn't a ramp, it's a vertical wall.
So, to summarize this deep dive, the ComfyUI package on the Arch user repository is technically brilliant under the hood. It gives you perfect system isolation, clean directory structures, and a beautifully designed web interface. But it absolutely requires manual model acquisition. For a newcomer, getting from that initial pacman install command to actually generating your very first image is a multi-hour process of trial, error, terminal commands, and deciphering ambiguous file types.
But if we connect this to the bigger picture, it is crucial to validate that the effort is actually worth the frustration.
You think so?
I do. The onboarding is undeniably rough. But once you have those core models in place, once you understand the difference between a checkpoint and a LoRa, the node-based paradigm of ComfyUI is a revelation. It is incredibly fast, it is infinitely flexible, and it gives you a level of granular control over AI generation that is hard to find anywhere else. The destination is spectacular. It's just the road there that is full of unmapped potholes.
This concludes the podcast. Thank you for watching. I hope you have found this podcast useful, and as always, if you have any constructive comments, I would like to read them, so drop them in the comments section below.